So good afternoon, everybody. Welcome to the third Big Data Pilot Demo Day. Let me start sharing my screen while people are joining. Is this visible?
Yes.
It is, Marek.
Okay, good. So let's give one more minute for people to join. So good afternoon, everyone. Welcome to the third Big Data Pilot Demo Day, a BigDataStack seafarer's tale of real-time shipping, featuring this time Stathis Plitsos, Head of Development at DCP Technologies, and Yusuf Moati, Senior Researcher at IBM Research Haifa, and an invited speaker, Despina Kopanaki from I-BiDaaS project and fourth organization. So my name is Monique Willems from Trust IT, partner in the BigDataStack project. I'll be moderating today's online demonstration. Thank you so much for joining us today. We are very excited to share with you the demonstration of the BigDataStack pilot on real-time shipping, on real-time ship management in Danaos. But prior to getting started, I'd like to review a few of the technical details that belong to the webinar. So first, the webinar is in listen-only mode. That means that you can hear me, you can hear the speakers, but we can't hear you. This prevents everyone on the line from having some unnecessary background noise. But we do, however, invite you to pose your questions in the question and answer box you find in the lower half of the at the bottom of the Zoom interface. We can see your questions and we can then answer them written, but we will also take them to the question and answer moment at the end of the presentations. Where you will also have the opportunity to speak. We can unmute you easily, so you can ask your questions with audio if preferred. Then rest me to say that the webinar will be recorded. The slides and recordings will be made available in a day or so, and you'll also receive them via mail. So. Today's webinar with the speakers. You can already see them here online with us. Then the agenda of today is we'll start off with our invited speaker, Despina Kopanaki from Forth. She is from the I-BiDaaS project, and she will explain the BigDataStack, the Big Data Pilot Demo Days, the joint effort by the BigDataStack, Track and Know, I-BiDaaS, and Policy Cloud projects. Then Stathis Plitsos from Danaos will be telling the seafarer's tale. He will be setting the requirements for the Danaos real-time shipping pilot. After that, Yusuf Moadi from IBM Research will be translating these user requirements to the BigDataStack architecture and already provided some insights in the technologies that we have there. Then Stathis Plitsos will run us through a BigDataStack demonstration in the deep sea user interface. And after that, it's time for your questions and answers. But now we would also like to get an understanding of who we have on the call, so who you are. We've defined a series of questions, which you see now on the screen, but I'll be asking. Andrea, could you pop up the online poll? Thank you.
Sure, Mike. So currently, our attendees should be able to see the poll running, and they should be able to answer the questions. So it's a set of 9 questions in multiple choice that they can just answer. And there are more general questions about the provenience of our attendees and more specific ones about how technical savvy they are, for instance, or if they are familiar with some technologies like the one of the complex event processing. I don't know if it's only me, but question number 7 is, are you familiar with the concept of object storage? But the word storage is not appearing for some weird reason. If you go over with your mouse, you should be able to see the missing word. So you're just hiding behind. Okay, we have a number of people from research academia field, Marik. And very few people answer the questions. Okay. Many of them are working in the shipping industry, and all of them with big data. So this is quite nice to know. So we have a technical public today. Nice for our speakers to know. Most of them are interested in big data technologies. As main barrier to the implementation of big data analytical solution in their own organization, they see the shortage of expertise in the big data field, as long as some uncertain value. So not grant on the return on investment. Quite middle and high technical savvy audience as well. Half of the audience is familiar with the concept of object storage. Then we have the 70% of them that are familiar with the concept of complex event processing. Well, yeah, as many of them come from the research academia, they are not properly working with within the shipping domain. So this is an information for Dr. Stathis Palitsos to know, maybe. I think 10 seconds more to answer the questionnaire, and then we can close. Marik, what do you think?
Good, yes. Yes, we can close the poll.
Yeah.
We have a nice overview. Thank you. Yeah, we have a nice overview of who is on the call. It will also help Stathis Palitsos and Joseph Moati for their explanations. So now I would like to pass the floor on to Despina Kopanaki. She's project manager at 4th ICS and a PhD candidate in information at the Department of Informatics, University of Piraeus, Greece. She holds a Master of Science in Applied Economics and Finance from the Department of Economics, Athens University. And she's managing I-BiDaaS H2020 project. And before that, she has been involved in several EU-funded projects as a researcher and a financial project administrator and manager. And her research interests include data mining, data analytics, and privacy preservation of mobility data. Despina, the floor is yours.
Good afternoon. Many thanks, Marik, for the introduction. Many thanks for your invitation. As Marik said, I'm a project manager at 4th. 4th is coordinating the I-BiDaaS project. So let me say a few things about this Big Data Pilot Demo Day series of webinars. As you are aware, Big Data Value PPP Summit 2020 went virtual due to the COVID-19 outbreak. So this pushed us for new way of thinking and new ways of collaboration. So why Big Data Pilot Demo Days? Marik, if you can go to the next slide, please. What is the common ground that we discovered? The new data-driven industrial revolution highlights the need for big data technologies to unlock the potential application domains. Big data value PPP projects, I-BiDaaS, BigDataStack, Track and Know, deliver innovative technologies to address the emerging needs for data operations and applications. The projects onboard pilots to show their applicability in a wide variety of sectors and to fully exploit the sustainability of the developed technologies. All the projects, the three projects are in the third and final year, are ready to demonstrate their solutions and their developed technologies to you, to interested end users from industry and technology providers for further adoption. In the next slide, you can see the list with the projects that join their forces. BigDataStack, holistic stack for big data applications and operations. I-BiDaaS, industrial-driven big data as a self-service solution. Track and Know, big data for mobility, tracking knowledge extraction in urban areas. And Policy Cloud, cloud for data-driven policy management. Actually, Policy Cloud is in the first year, and the aim here is to show the adaptability of the mature technologies developed in BigDataStack project to the policy domain sector. So all these projects join their forces to show their application in different domains like finance, telecommunication, manufacturing, shipping, insurance, healthcare, and so on and so forth. And in the next slide, you can see an overview of the series of webinars. We have designed 10 webinars. Today we have the third one, and by the mid of July, we plan to conclude this series. Don't forget to visit the Big Data Value webpage for webinars. We constantly update the content there. You can also find all the related information, registration links in our websites. And of course, if you want to go back and if you have missed a webinar, then you have the opportunity in our YouTube channels and website to see again the webinars. So Marika, again, many thanks for the invitation. Back to you.
Thank you, Despina. So now we pass on to Dr. Stathis Pitsos, Head of Development at DeepSeek Technologies. He's a senior researcher and head of development at the DeepSeek Technologies and proud member of the DANAOS Corporation. He holds a PhD in operations, research and decision support systems, and he has worked in many national and European research projects over the past years. He focuses on IoT, big data optimization, and artificial intelligence approaches for the shipping industry. Stathis Pitsos, over to you.
Okay, I was muted and was talking to myself. Sorry about that. Hope you all can see my screen, even in presentation mode.
Yes, yes, perfectly.
Then I'm about to tell you about the seafarer's tale, which we inside BigDataStack call it real-time ship monitoring. I'm Stathis Pitsos, Head of Development at DeepSeek Technologies, as Marika said, part of the DANAOS Corporation. And I would like to share the business requirements of our pilot. First, a few things about the DANAOS Corporation. We're one of the largest independent owners of modern large-size container ships. We have a proven track record of operational excellence and technological leadership. Our distinct edge in advanced shipping technology and long track record of safety, efficiency, and environmental responsibility helped us forge lasting relationships with our customers. And our deep understanding of the shipping domain, given all these years that we're involved into shipping, allowed us to get involved quite early, somewhere in the middle of 80s, into software for shipping as well. So apart from shipping services, we offer software services for the shipping domain. And I will focus on a specific service we offer that is about real-time ship management. The objectives of such a tool on which we focus are related to fuel consumption tracking, hull drag optimization, which is how dirty the submerged part of the vessel is, machinery troubleshooting, meaning having a close look on the data flowing out of the main engine or the generator engines of the vessel, and identifying patterns that pinpoint malfunctions. And last but not least, the environmental compliance of the crew with respect to the IMO policies and the company policies. How we do it? Being on board, installing sensors, collecting data from different systems from the vessel, which are sent over a satellite connection to our data houses, and we also augment this data with meteorological information given the vessel position at a specific time. And this is where we use artificial intelligence to estimate the performance of the vessel. All these end up into some very nice screens for the end user to have a close look on the performance of the vessel she owns. So in order to collect data from the vessel on board, many things have to be taken into consideration. This is just, a bare minimum information on what is required from IoT devices on board. We're talking about marine appropriate materials, okay, that can last to humidity and high temperatures. And also the data transmission between all devices should be secure, and the network of devices should also be scalable, meaning that we must be able to collect data from any point of the vessel. This is quite difficult considering that the vessel is a metal box and wireless communication is not as easy as it could be in other domains. In any case, this is more or less a solution we offer for an AI-enhanced monitoring of the vessel. We believe, given the market needs, that simple data logging is not a solution anymore, because ignorance and over-information are the two sides of the same coin. So if you get way too much information with no action on what you should do, it's more or less useful, useless these days. So actionable information is required from the end user, and analytics over big data is mandatory. So we offer a solution that is based on IoT, discusses about analytics, and needs an infrastructure behind that is capable to support all these requirements. I'm going to deep down into what we wish to do in the framework of BigDataStack, and I'll tell you right now the seafarer state, which for which I started talking about. So we all know that vessels have time-constrained routes. The thing is that when a main engine part fails unexpectedly, the vessel may go off hire, which is very bad. It's very bad for the company image, and in particular, chartering revenues decrease, while replacing immediately the broken part increases cost. So finding potential failures allows us to timely order the spare part and replace it before failure. The thing is that, okay, we're talking about malfunctions in the main engine of a vessel. Well, you don't have to be deep into shipping to understand that this is a vast problem. There are many things that can go wrong. So we focus on a very specific malfunction, which happens on a part of the cylinder called crosshead bearing. This is a malfunction that evolves gradually, so it's not a sudden event. But to the best of our knowledge, we don't know a correlation to predict it. We can only detect it with an onboard inspection. So someone has to get literally into the cylinder, have a look on the crosshead bearing, and decide whether it's it's going to break or not. However, we know the reason. We know why this malfunction happens. It is caused due to slow steaming. Slow steaming is a very common practice imposed by charterers. It is used basically to save fuel, but main engines are not designed to work optimally in such slow speeds. So this causes bad lubrication of the cylinder. The thing we wish to do, we wish to predict these breakages, okay? And we strongly believe that as a physical phenomenon, it's somewhere hidden in the data. So we wish to reveal it, okay? On the left-hand side of this slide, you can see the higher level architecture of the cylinder. Somewhere in the middle, you can see the crosshead bearing. So you can see that it's a not very important. It's right in the middle of the cylinder, so it makes it crucial. On the right-hand side, you can see an article from Sea Trade Maritime News explaining the economics of slow steaming. This is more or less a statement saying that slow steaming happens, and will continue to happen. Still, main engines are not designed to work on such slow speeds, and this is a case that we wish to address accordingly. We have some technical challenges. There are many parameters related to this malfunction. So it is very difficult to accurately predict failures. We also have an issue with data loss due to broken sensors on board. It's a very difficult environment with a lot of humidity and high temperatures. In general, identifying a malfunction pattern seems to be data intensive and computationally demanding. The operational challenges we're facing, we know that premature alarms increase the operating costs because ordering unnecessary parts is something that is not wishful in general. Spending money, stocking parts that are not necessary, etc., etc. Additionally, the part replacement price depends on three questions: where the replacement will be performed, when will happen, and who will do it. The used data we provided into BigDataStack for this problem can be split into roughly into three categories. We're talking about operational data. We use the old school term telegrams, which is more or less reports that the captain manually fills and sends every 12 hours or upon arrival and departure. So the total data set of this category sums up to 47,000 records. We have general purpose sensor data from 21 different sensors on board, summing up, which records sensors that collect values on a per minute basis. And given the number of vessels for which we provided data, this adds up to 60 million records. And last but not least, we're talking about main engine sensor data from 100 different sensors. That again adds up to 60 million records and are on a per minute basis. Someone could say that this number is not a very large volume of data, but considering that the previously described service is not sold as a software, but as a service, okay? And we have a number of contracts that is ongoing and expect a big rise in the number of monitored vessels. The volume we already monitor, we strongly believe that it will increase dramatically. So we need a solution that is scalable and can support all our customers efficiently. This is my part. Up to this moment, I described you the business requirements. I'm about to let my co-worker and our coordinator, Joseph Moati, describe the details on the architecture. as far as any IT person can understand, all components of the provided infrastructure from BigDataStack are utilized. However, I would like to highlight 4 components that are of major importance for this use case. Joseph will explain in detail what I do. So we're talking about real-time stream processing by distributed complex event processing. And we use this to identify, first, sensor malfunctions that happen on board in order to tackle the data loss we described, and some very crucial business rules violations. The second one is the preventive maintenance algorithm, which uses the data quality assessment service of BigDataStack and efficiently predicts malfunctions on the crosshead bearings. Third, the seamless data movement and data analytics that is offering a scalable way to query data, fresh and historical data that reside in 2 different physical storages, and enhanced SQL query performance via data skipping technologies from IBM. Thank you very much. Joseph, I think this is your turn now.
Okay.
Thank you, Stathis. Yusuf, shall I briefly introduce you? Yusuf Moati is, as Stathis already mentioned, the coordinator of BigDataStack. So he's a senior researcher and head of development he's a coordinator and senior researcher at IBM Research Haifa, and his research interests include big data analytics and storage frameworks, and he has a doctorate in computer science from Telecom Paris Tech and coordinator of the BigDataStack project. Yusuf, the floor is yours.
Thank you very much to all of you. And thanks very much for Stathis for presenting the business goals of the Danaus Corporation, at least in the context of the BigDataStack project. So what we aim to do now is to look at the data services that were built in the project, in the BigDataStack project, and to see how this helps the Danaus use case. So, excuse me. Okay, so we start with a fleet of vessels. And as Stathis has just explained, the engines have been instrumented with the sensors, which stream out IoT data. This data is sent to the Danaus data center. And the first component that I want to present is a complex event processing, and this component permits first of all at the edge, that is within the vessels, to detect bad sensors. So the IoT data is examined, and in case there is a high probability that the sensor is bad, then an alarm is created and sent along with the IoT data to the data center. Once the flow of IoT data comes within the data center, it is once again gets through once again the complex event processing, but this time the goal is to detect a business rule infringement. This is a simple illustration of possible business rules. It could be, for instance, that a rolling average of full consumption should be within a such or such range, as derived from the SLOs that was signed with the particular customer. So if a business rule infringement is detected, then an alarm is created and also sent along with the stream of IoT data. You can see that not only we have the data is flowing toward the database, the lean scale database, but also from the database, some information is retrieved, and this is related to the business rules which have to be retrieved from somewhere. So that completes the data ingestion and its processing prior to being ingested within the lean scale database. So the lean scale database, in fact, will be used for storing
I think Yusuf just frozen.
Database. So,
Yusuf, sorry.
So first of all,
we have to ask you to step back 1 minute because you froze.
Can you hear me?
Yes, now, but you stopped for, let's say,
connection. Can you hear
15
me?
seconds. Yeah. Okay. Thank you, sorry.
Okay, so can you hear me, Marika?
Yes, yes, we can. We just need you to rewind back for half a minute. The same slide. Yes, perfect. Thank you. Yusuf, you were the slide you showed.
Marika, can you?
Hi, we can hear you. Yusuf,
okay,
we can hear you.
Be heard.
Yes, we can hear you.
So,
but we can't see the slides now.
So let's go on. So the first component which taps on the recent data on the lean scale database is the data quality assessment. The data quality assessment will be described in a few minutes. The second one are the machine learning programs, which in fact are the goal, which is to detect possible and probable breakage in the engine. And finally, we have applications such as the Danaus UI, which are also retrieving data from the database. So this is for the recent data. But what if these services or application want to retrieve historical data? So this can be done by accessing object storage, which might be either local or remote. And here comes a problem, which is that in fact your logical data set is within two places potentially. So here comes the seamless component, which goal is to present for retrieval a single logical data set. That is, the user of the data is not even aware of where exactly is data is being stored. So this is for data retrieval, since data ingestion is directly done to the lean scale database. So this seamless component presents a single access point, and underneath what when an SQL query, for instance, is sent through this access point, it is forked into two separate queries, one for the lean scale database part, one for the object storage part through the Spark SQL framework, and then partial results are merged back and presented to the requester. For doing all this, obviously we need a component which moves data from the database to the object storage. This is done through the data mover, which periodically moves historical data slices. Now, it is important to see that the transactional semantics are preserved, while even when data slices are moved to the object storage, and also this has negligible impact on query performance, which is not a small feat. Now that we understand the seamless components, so we can see that services, in fact, instead of a direct connection to the Linscale database, may just connect to the seamless component and retrieve data from either the Linscale database side or from the object storage. Now let's have a quick look at three components. The first one is data quality assessment. This will be presented more thoroughly by Statis after I complete my presentation. So the data quality assessment, the goal is to assess for each one of the IoT records whether it is probably a very good record or maybe a faulty one. So this is learned, and this component is data set agnostic, and this is learned, and the model is built, and the data as it comes in within the Linscale database is assessed, and we get a probability of being a faulty record for each one of the ingested records. The second component is the machine learning, the very goal of the business that is to know in advance when an engine might break. So here we present two graphs. On the x-axis you have time. On the y-axis you have the probability that a breakage is in the engine is about to come. So what are these two? What are these two parts? On the left part, we have processed data without cleaning it. That is, without getting through the data assessment quality, and thus we get, in fact, quite a probability which is not informative. We get all more or less always the same thing, while on the right part you can see that the probability is this time very differentiated. Now I will make appear the actual time of the breakages. So this is for the left part. So as we said, this is not very useful, while on the right part, that is when the machine learning programs that were developed are tapping on the data quality assessment service, we get a very good prediction, which is very informative. Now, the last of the three components through which I will get very quickly is the DANOS user interface that the Statis will show us in the demo. So this is tapping on the data set data, and also permits, as you will see, to retrieve and display alerts from the Linscale database. Now we come to the last service which I want to present, and which is the data skipping. So data skipping, what is it? It is in fact some addition to the Spark, Apache Spark framework, and it permits to make big performance improvements. How do we do that? So first of all, this technology of the data skipping is relevant for SQL queries. Here you have an example coming from DANOS, that is to retrieve data that is pertaining to violent storms. This technology has been implemented for the Apache Spark framework, but it could be in fact implemented with other frameworks. So this is a standalone technology, but on the other side, it nicely complements the seamless component, since the performance of object storage is obviously less good than the Linscale database on retrieval. So making things quicker is very important. So given an SQL query, we have it addresses a data set, which is represented by a set of objects. Now, the goal is to be able to skip over non-relevant objects. How this is done? This is done by indexing and keeping an index of for each of the objects which summarizes the content of the object, and in fact permits to skip it if it is not relevant for a given query. So what happens is that through this index we are able to retrieve the possible relevant objects and to ingest them within the Apache Spark compute cluster, thus relieving us of a lot of time and money also. And this is a very quick explanation of the data scaping. Now, this technology is in fact was already used by other technologies, but we have extended it to encompass now many other situations which are not dealt with in the industry, such as user-defined functions. I can't now enter the details. And also we have integration with the geospatial and a lot of goodies which make this technology very attractive. And in fact, this technology has been demonstrated 1 year ago in the IBM Think conference, and in fact, this is already integrated as an open beta within the IBM Cloud SQL technology query service. And so the answer of when can we use it? You can use it now, just by connecting to the IBM Cloud SQL query service. Now, for a very quick recap, we have presented complex event processing, data quality assessment, predictive maintenance, the lean-scale database, which is integrated with the CEP, seamless component, data scaping, and last but not least, the integrated Danaos platform with all the services of the project. What's next? We have a lot of things in the oven. SEP and lean-scale database are now will now be able to scale up, scaling automatically. And we have a lot of improvements. I can't get now into all the details. So this is a partial list of what is in the queue of the improvements. Thank you very much. That's all.
Thank you, Yusuf. Now it's over to Stathis Plitzos. Can you take the floor? Thank you.
Yes, I'm sharing my screen. Can you see it?
Yes.
Okay, perfect. I will show you a demo of the platform, the end user screens that all these data from IoT devices and the alerts of broken sensors, the alerts of business rules violation that are generated from CEP, and the alerts from the preventive maintenance algorithm. So we have integrated all these solutions, and the platform is, let's say, hosted into BigDataStack. So we utilize all these components to make it more robust, scalable, etc., etc. So what you see right now is the latest vessel positions with the global weather conditions. This is a specific fleet that is comprised of 6 vessels. On the upper left corner on the bell, you can see the populated alerts. So this is a list of alerts indicating that we have first a crosshead bearing alert, which is generated from the predictive maintenance algorithm. We have a violation of the agreement of a business rule, which is basically the charter party agreement, a contractual agreement between the charterer and the ship owner. So this is an alert that that we exceeded the consumption, but normally this is caused and justified due to weather conditions. So in any case, we wish to be alerted and ready to justify if questioned, to justify this violation if we're questioned. And the last three alerts you can see on this small list are alerts that refer to broken sensors. So if I choose to inspect all alerts, I get to see a closer look on the generated notifications about CP1 alerts. This is the first category, which is the broken sensors alert. In the middle of the screen, we have the crosshead bearing alert. So this is generated from the algorithm of preventive maintenance. And last, the fuel overconsumption violation, which again is generated by CP. So we get to use all these components, integrate them and successfully use them through this and successfully visualize the results of these components. While we strongly believe that even if right now, again, one could say that the data is not so big, we believe that given the demand for vessel monitoring in the shipping industry right now, and the customers that are practically waiting for us to install IoT devices on their vessels, we strongly believe that the number of monitored vessels will increase dramatically. So we have to be in the position to tackle the increasing volume issue. And BigDataStack is one thing that indeed paves the way towards that direction. So from my part, that would be all. I think, Mariki, now is the time for Q&A, right?
Yes, while we prepare for Q&A, I would like to ask Despina to tell us something about the next. So Despina, while we prepare, people can already start typing in their questions in the Q&A. I would like to pass the floor on to you, and then we have the time for the Q&A. Thank you, Despina.
Thanks, Marik. Just 1 minute to introduce you to the next webinar, Big Data Pilot Demo Day 4. It is I-BiDaaS application to the telecommunications sector. So on behalf of the I-BiDaaS consortium, I would like to invite you to join us next Thursday, June 25th. We do have two speakers, Dr. Dusan Jakovetic. He is an assistant professor at University of Novi Sad, and also the I-BiDaaS scientific and technical manager. Dr. Ioannis Arapakis, he is a researcher at Telefonica. So in this webinar, we are going to demonstrate in a step-by-step fashion our self-service solution for both experts and non-expert users. The big data pilot is Telefonica. Telefonica is one of the largest telecommunication companies operating in 16 countries in Europe and Latin America, with more than 350 million of customers. So we're going to demonstrate interesting use cases like quality of service in call centers, chatbots, where the goal is to predict the customer satisfaction index, use cases for mobility data, optimization of placement of telecommunication equipment like antennas, accurate location prediction with high traffic and visibility to optimize the resource distribution. So book the date in your calendars. We will be more than happy to have you in the next webinar. Marik, thanks again. Back to you.
Thank you, Despina. So I can't see the question and answer box, Andrea. Are there any questions in at the moment?
So Marik, actually there are no questions, but I have one maybe for Dr. Plitzos. So what if I would like to adapt this real-time ship management to another kind of, let's say, kind of fleet? So what about trains, for instance, or airplanes? Will it be possible to adapt such kind of monitoring and insight gathering, for instance, to a train fleet?
Well, if you go a step back and see it from a larger distance, I mean, big data stack. And what we practically do, we're talking about IoT data, okay, flowing into a system using analytics and streaming and stream processing in order to get some results. So yes, I strongly believe that the solution of big data stack in principle is transferable to a completely different domain. For example, as you said, airplanes or factories. Preventive maintenance is a case that stands there as well. The thing is that, you know, some details have to change. For example, the preventive maintenance algorithm is not the same. The data rate will not be the same. I suppose if we go to the airplane case, I was talking about data flowing out of metering device per minute. I would expect that, you know, given the severity of, you know, carrying people in the air is, you know, crucial and very, very important for security reasons. I expect that monitoring of components is being performed in a higher rate. So we're talking about more data. In any case, Big Data Stack has proven that has the capacity to do it. And yes, I believe that it is transferable with minor details, such as the predictive maintenance algorithm.
Thank you.
Oh, thank you.
Any questions that that come in from the audience?
Actually, no, Marik.
I do have another question now that you talked about implementation. So this is both to Youssef and Statis. So you talk now about the implementation that you had in Danos. So how long, now that the Big Data Stack solution is, I mean, we're in the third year of the project, so the solution is quite ready. So how long would it take for an organization, for a shipping organization to implement that in their own environment? And are there any requirements that are essential to take into account?
So, start if you want, please.
Okay. There are some requirements. In order to set up properly Big Data Stack, I see two different roles within the organization that is about to use it, should work hand by hand. The business analyst and the data analyst, which is quite common. I mean, the business analyst gives requirements to the data analyst, and the data analyst provides a solution. Indeed, the basic requirements is that these two roles within an organization, in order to first set up data stack, is important. Then I would say that more or less it follows the path of an IT project, but in a more interesting way. Meaning that requirements should be collected, many tests should be performed, testing designs, etc., within the organization in order to release it. So I cannot give you a straight answer on the required time, but I could describe you how the organization would use it.
Thanks.
Okay.
Joseph, do you want to add anything to that?
No, that's okay.
Because I have another question for you. So the full solution is built of, we saw that already in both your presentations. So the full solution is built up of services that in their capacity have individual components. So how could, are these adoptable individually as well? So we've seen the full solution, but can organizations that may be on the call also adopt the individual components within this solution?
Yes, certainly. In fact, most of the services are standing alone. It was very nice that we made them cooperate to build a solution for the Danaus use case. But you see, we have the IBM as is presenting the datascaping technology within its services. This is standalone. The CEP is also standalone. The data quality assessment is also standalone. It doesn't matter from where it gets the data. So the machine learning also. So in fact, the only component which is the seamless is a cooperation of both IBM and the Linscale company, and this component is not now publicly available. However, the Linscale database is a product, so the seamless is the only component, in fact, that is not readily available for now. But apart from this, some user may take any of the other components separately or not, and that would be okay.
Okay, thank you. I don't know if there are any questions that came in just now from the audience. Andrea?
So, no, Marie.
No?
I think we're done now.
Okay, then I would like to thank everybody who joined the webinar. If you have any questions, you can contact us via the BigDataStack project website, where you can see here below. You can follow us on the social media for our latest updates. And I would like to thank very much our speakers of today. So Stathis Plitsos, Joseph Moati, and Despina Kopanaki. Thank you very much. And have a nice day.
Mariki, Andrea, and Diego, thank you for making this event happen. Okay.
Thank you.
Yeah. So
Have a nice day.
Have a nice day. Bye.
Bye.
Thank you. Bye.
Bye. Bye.